Okay, so exponent rules. Let's talk about when we're adding. So if I have like terms, for example, 3x to the second plus 4x to the second, what's the rule for adding like terms? Ariana?
Amanda.
Oh, no, Ariana's the behind you, right?
Sorry.
Yeah.
You add the coefficients and then put the variable.
Good. When you're adding like terms, you just add the numbers in front, you keep the variable the same, so we are 7x squared. Let's say they have the same variable but not the same exponent. Can we add them? No. This is already simplified. It's 3x squared plus 4x. Nothing more we can do there. All right, so that's addition. Let's go to multiplication. So now the rule for multiplying tells us, let's say I have x to the a power times x to the b power. So if I have x to the a power times x to the b power, you keep your base the same. Who remembers what you do with the exponents? I want to say Charlie, but
yeah,
no.
it's Charlie.
Oh, okay, Charlie.
A plus B.
A plus b, you got it. So if I have x to the fifth power times x to the third power, what does that give us? X to the eighth power. Let's add in some coefficients now. Let's say I have 3x to the fifth, y to the fourth, times negative 2x, y to the third. This is still a monomial, right? When we have polynomials, a monomial is one term, a binomial is two terms, a trinomial is three terms. Anything bigger than a trinomial, we just call a polynomial. So these are still monomials. What makes a monomial different than, let's say, a binomial? Like up top for addition, those were binomials. What's the difference between a monomial and a binomial? What makes it different, I should say?
The number of terms.
How do you know how many terms it has? Because somebody could say, oh, that looks like 3 terms. How do I know that's all just one term and not 3 terms?
Oh, that's a singular product. It's not like separated by like.
Good. It's not separated by a plus or minus sign. A plus or minus sign, that creates the terms. If there's no plus or minus sign, this is all one term. If I had a million different things next to each other all showing multiplication, it is still just one term. It's still a monomial. Right? So this is a monomial times a monomial. What you do is you multiply the coefficients. So I have 3, oops, don't want to scribble that. I have 3 coefficient times a negative 2 coefficient, which gives us a negative 6 coefficient. And then you multiply the like variables. So when I have x to the fifth times x, what exponent does that second x have? 1. When nothing's there, it's a 1. So x to the fifth times x to the first, we're going to keep our x and do what with the exponents? Add them. So 5 plus 1 is 6. So it's x to the sixth. And then we have y to the fourth times y to the third is going to give us y to the seventh. Okay, let's say we have variables in our exponents. X raised to the a plus 5 times x raised to the a minus 2. It's the same idea. You keep your base of x, and then you add your exponent. So I'm adding a plus 5 plus a minus 2. And I combine my like terms. An a plus an a is a 2a. And then I have a positive 5 and a negative 2 is a positive 3. So we get x raised to the 2a plus 3 power. Okay, same thing. I have two monomials that are being multiplied together, so I multiply the like variables. So I have x raised to the a plus 3b plus b minus 2 power. And then I'm going to have y raised to the 2 plus a power. When I'm simplifying, can I add the exponent on the y with the exponent on the x? No. You could only add the exponents that have the same base. So here we're going to have x, and then I'm going to have a, and then 3b plus b is a 4b, minus 2, that's as simplified as that exponent can get. And then the y, I always like to put the variables first, a plus 2. But if you wrote y raised to the 2 plus a, you're perfectly fine. Addition's commutative, it doesn't matter. Okay. I want to compare 7 to the 5th power times 7 to the 4th power versus 7x to the 5th times 7x to the 4th. In the second one, in this problem we have here, is 7 the coefficient or the base?
Coefficient.
It's the coefficient. In the first one, is 7 the coefficient or the base?
The base.
The base. Very, very different. In the first one, since 7 is the base, and they're like bases, right? They're both a base of 7. We keep our base of 7, and what do we do with the exponents? Add the exponent. So this is 7 to the 9th power. My rule is going to be, if the exponent is 5 or less, you multiply it out. If it's more than 5, you're going to leave it in exponential. So 7 to the 9th power, we are allowed to leave in exponential, leave it just like that. But if it was 5 or lower, you'd multiply it all out. All right, now this other one, 7x to the 5th times 7x to the 4th, you multiply your coefficients and you get 49x to the 9th. Very different problems here. I will tell you, the biggest mistake that I see on the test is that students write a problem like this as 49 to the 9th power. We don't want to make that mistake. It's not 49 to the 9th power. The 7 is a base. It's not a coefficient.
So you said if it's lower than 5, then you would multiply it out.
5 or lower, you multiply it out.
If it was like 4 times 4, you would add the exponent to like 16.
No, so if it was, let's say, pick an easy number, 2 to the 5th power, it would be 2 times 2 times 2 times 2 times 2, which is 32. That's what I mean, multiply it out. Okay, let's keep going. 5, 6. Is 8 a base or a coefficient? It's a base. What does the rule say? Keep your base and do what with your exponents? Add them. So I'm going to keep my base of 8, and I'm now going to add 2a plus 1 plus 4a minus 3. That last 8, what does it have an exponent of since nothing's written there? 1. So plus 1. Don't forget that plus 1. And now we combine our like terms. So 2a plus 4a is 6a. And then we have a positive 1 and a negative 3 and a positive 1. So 1 plus 1 is 2 minus 3 is a negative 1. So we have 6a minus 1. Or sorry, 8 raised to the 6a minus 1 power. Okay, so that's multiplication. Let's go on to dividing. I'll let you finish copying this. So the rule for dividing is if I have the same base being divided, the rule says keep your base and do what with your exponents? Subtract them. Let's also talk about negative exponents. Who remembers if I have x to the negative second, who remembers how to make that positive? Only 2 people out of a whole class. Leo?
You go like under 1, so like 1 over x to the 2.
Yep, you put it in the denominator or you move it into the denominator and make it positive. Let's say I was already negative, let's say it was negative in the denominator. How would I make that positive? Next to Charlie is Maria. Yep, you move it up to the numerator. So if it's negative in the numerator, you make it positive by putting it in the denominator. If it's negative in the denominator, it's positive by moving it into the numerator. Okay, let's do some problems. Simple x to the 7th divided by x to the 2nd. Because they have the same base, what you do is you keep your base and you subtract your exponents, so we get x to the 5th power. Let's throw in some coefficients here. 4x to the 10th divided by 24x to the 6th. A lot of students want to subtract the coefficients. You're not subtracting. What operation are we doing? Division. Even though the division rule says to subtract your exponents, we are still dividing. So when we're dividing the coefficients. Does 24 go into 4 evenly? No. But can I reduce 24 over 4? Yes. I can divide top and bottom by 4. So then our coefficients become 1 in the numerator and 6 in the denominator. Do I need that 1 in the numerator? As of right now, no. And then you divide the variables. X to the 10th divided by x to the 6th is x to the 4th. Wherever the exponent is bigger, that's where your variable goes. So since 10 is bigger than 6 and 10's in the numerator, my x to the 4th, that quotient goes in the numerator. Coefficients, can I divide those? Yes. 10 divided by 5 is 2. Where? Numerator, right? It's like dividing top and bottom by 5. That's what we're doing. We're essentially dividing top and bottom by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. I don't need to put that 1 in the denominator. Now, x to the second divided by x to the 7th. You could either do the multiplication of the division and say, well, 2 minus 7 is negative 5, right? And then to move that negative 5 to make it positive, we'd move it to the denominator. Or what I do is just say, okay, well, there's 7 x's in the bottom and 2 x's on top. Obviously, my quotient will be where? In the bottom, wherever there's more x's. So this is going to be x to the 5th in the denominator. So I saw a lot of mistakes, like not a lot, I shouldn't say a lot. I saw a handful of mistakes like this on the test. So let's talk about this. Are these the same or different, these two problems? They're different. How do they differ? Ariana?
The first one you're multiplying the terms, and the second one you're adding.
Good. The first one we're multiplying, and the second one we're adding the numerator, we're adding the denominator. The rules for dividing are very different. When it's just multiplication between everything, and there's the same thing on top and the bottom, we can cancel out. Y to the second divided by y to the second cancels each other out because it's multiplication between them. We're treating the x and the y separate. And then we can keep on dividing. X to the 7th divided by x to the 5th is x to the second where? Numerator. All right. I saw a lot of that. And then they would go further and say x to the 7th divided by x to the 5th is x to the second. We can't do that. We cannot do that. The minute you add a plus or minus sign, we cannot cancel out. I now say the minute you add the plus or minus sign, it's now a union. It is a family. You cannot take out part of the union. Either you take out the whole family or you let them be. So yeah, it's a little sad, right? You don't want to just kill part of the family. So what's happening here is you keep them together. So x to the 7th plus y to the 2nd. The minute we add that plus or minus now, they are a family. You cannot just cancel out part of the family. Either you cancel out the whole expression together or you leave it as it is. Had there been a GCF, you can pull out a GCF, and that's different. But right now, there's no GCF, and I cannot cancel through a plus or minus sign. So this is as simplified as we can get. That's it. Can't do anything. Yes.
If it was like x to the 7th plus y to the 2nd over x to the 7th over y to the 2nd, can you cancel out?
Over or?
Like, if it was like.
Okay, tell me again.
The numerators, if that.
X to the 7th.
Was the same as the denominator.
Yes. So if the numerator and the denominator are the same, that means the full family is exactly the same. So we're going to take them all out. So that would just be 1.
If it was like flipped on the denominator, like y to the 2nd plus x to the 7th, could you still cancel it?
Yep, because addition's commutative, right? So if I have y to the 7th plus y to the 2nd plus x to the 7th, it's the same as x to the 7th plus y to the 2nd. So that's still same thing divided by top and bottom gives us 1. You're welcome. Okay, moving on, let's do some more. Let's step it up just a little bit. What was that for? 5. X to the 6a minus 3 over, 2x to the 6a minus 3 minus 4x, divided by 4x to the a plus 2. I see coefficients. What coefficients do I see? 2 and 4. What does that simplify down to? A half. Do I need that 1 in the numerator? No, so I could put a 2 in the denominator. Then I have x to the 6a minus 3 divided by x to the a plus 2. We keep our base and do what with our exponents? Subtract them. So this is going to be 6a minus 3 minus. But aren't I subtracting a whole binomial, a plus 2? Do I need parentheses around that a plus 2? Absolutely, because I'm not just subtracting the a, I'm subtracting the a and the positive 2. So we have to have those parentheses to distribute it in. So we end up with x raised to the 6a minus 3 minus a minus 2 all over 2. We're going to combine our like terms. So we're going to have x raised to the 5a minus 5 over 2. Okay, one more division problem. All right, let's do this. 5 to the 4th divided by 5. Is 5 a coefficient or is 5 a base? Base, what does the rule say? Keep the base as it is and do what with your exponents? Subtract. What exponent does the bottom 5 have?
1.
A 1. 4 minus 1 is 3. Can I leave it as 5 to the 3rd power? No, the rule says if it's 5 or less, we're going to multiply it out. So this is 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. Okay, so we reviewed addition. Oh, yes, Ariana.
Is there a rule about multiplying it out, like just in this class, or just?
No, just think of this class. It's just a rule I made up to make it easier for you. Okay, so we did addition, we did subtracting, we did multiplying, we did dividing. Now we're going to talk about a power to a power. Yes.
Can I go to the bathroom?
Yep. So the rule tells us if I have x to the a raised to the b power, so a power to a power, an exponent raised to an exponent, we're going to keep our base and multiply the exponents. X to the a raised to the b power is the same as x to the a times b power. So if I have x to the 3rd raised to the 4th power, that gives us x to the 12th power. You got it. Okay. These are very different. What makes them very different? Lily?
The second one, third, also applies to the two separate terms, so the 2 and the x to the fourth, and in the first one, it's like
Good. The first one is a monomial. What would we call the second one? A binomial. The first one's a monomial, the second one's a binomial. We would treat these very differently. So for the first one, when it's a monomial, when there's no plus or minus signs, you're allowed to distribute that exponent into anything in those parentheses as long as there's no plus or minus sign. So because there's no plus or minus sign, I can distribute in that exponent. So this becomes 2 to the third power, and then x to the fourth raised to the third. Well, 2 to the third power is 8. X to the fourth raised to the third is x to the 12th. Biggest mistake I see, biggest rookie mistake, is that students distribute in this exponent and get 8 plus x to the 12th. That is so completely wrong, to the point where I almost take off full credit when I see that. So you really don't want to do that. What does this mean? The minute you add a plus or minus sign, we are now having to multiply this out. What do I mean when I say multiply it out? This is 2 plus x to the fourth power times 2 plus x to the fourth power times 2 plus x to the fourth power. I'm going to only multiply 2 at a time. So 2, remember foiling it out? Remember this? 2 times 2 is 4. 2 times x to the fourth is 2x to the fourth. X to the fourth times 2 is 2x to the fourth. X to the fourth times x to the fourth is x to the 8th. Now I'm going to combine my like terms, so I have 4x to the fourth. Oh, sorry, let's put the biggest one first. X to the 8th plus 4x to the fourth plus 4 times 2 plus x to the fourth. So now I have to multiply this out again. I'm going to triple distribute. That's what I call this. We're going to triple distribute this. So give me a different color. Use black. X to the 8th times 2 is 2x to the 8th. X to the 8th times x to the 4th is x to the 12th. Good. 4, now I'm going to distribute in the 4x to the 4th. I'll double distribute it in. 4x to the 4th times 2 is 8x to the 4th. And 4x to the 4th times x to the 4th is 4x to the 8th. Last one. 4 times 2 is 8. 4 times x to the 4th is 4x to the 4th. Did I go too fast, or are you guys keeping up? Okay? Anybody confused with how I got this whole thing? All right, now we combine our like terms. So when I combine my like terms, I'll put the biggest exponent first, which is x to the 12th. So we're done with that. Then I have 2x to the 8th and 4x to the 8th, which gives us 6x to the 8th. And then I have 8x to the 4th and 4x to the 4th, which gives us 12x to the 4th. Anything match with the positive 8? No, so plus 8. This is very different than 8 plus x to the 12th, isn't it? All right, so moral of this problem is, if it's a monomial, can you distribute in the exponent? Yes. If it's a binomial or bigger, can you distribute in the exponent? Never. You have to FOIL it out. You have to keep FOILing it out. You have to keep multiplying it out. What distinguishes a monomial for things that other than a monomial? Plus or minus signs. Okay. So that was number 2. Number 3. Is that negative in the parenthesis? No. So in the first one, that negative is not in the parenthesis. Only the variables in the parenthesis get that exponent. So I'm going to distribute in that 4. Why am I allowed to distribute in that exponent of 4? Amanda? Because it's a monomial. So now I'm going to get x to the 5th raised to the 4th is x to the 20th. Remember, power to a power, you multiply, that's okay. Y to the 4th raised to the 4th power is y to the 16th power. And now that negative stays in front. And so our answer is negative x to the 20th, y to the 16th. So you just bring down the negative. Saying negative 1 is really saying that's your coefficient there. Where in the second one, is that negative in the parentheses? Yeah, so this is negative 1 raised to the 4th power, x to the 5th raised to the 4th power, y to the 4th raised to the 4th power. They all get it, even the negative. Negative 1 to the 4th power is 1. When you raise negative 1 to an even power, it's 1. When you raise negative 1 to an odd power, what is it? Negative 1, exactly. So we have positive 1, x to the 20th, y to the 16th. Do I need that 1 in front? No. If you wanted to put it, is it okay? Yes.
Does the negative in front of, like, for number 3, does the negative for the final answer also imply that the y 16 is negative?
No. So this is really just, it's not applying to anything. It's just saying negative 1 times x to the 20th times y to the 16th. Only one of them is negative. So if you wanted to make it like negative x to the 20th, y to the 16th, that's fine. If you wanted to make it negative y to the 16th, x to the 20th, that's fine. But only one of them is negative because it's multiplying. Okay, let's keep going. Number 4. Can I distribute in this exponent?
Yeah.
Yes. Why? Because I just said if there's plus or minus, you can't distribute in. Why am I still allowed to distribute it in? What's your name? Anish.
It's a monomial.
Good, because it's still a monomial. That plus or minus is in the exponent. It doesn't change that it's a monomial. So this becomes x raised to the a plus 2 raised to the 3rd power, y to the 5b raised to the 3rd power. Power to a power, we multiply. So this is going to be x raised to the 3 times the a plus 2 power. Is it important that I put that a plus 2 in parentheses? Yeah, because it's a binomial, I have to distribute it in. And then this just becomes y to the 15b. Distribute in that 3. So we have x to the 3a plus 6, y to the 15b. If I have 2/3 raised to the 2nd power, do you agree this becomes 2/3 times another 2/3, which gives me 4/9? So essentially what has happened? I got 2 to the 2nd power and 3 to the 2nd power. Do we agree? So what happens when we're raising a fraction to an exponent? Maria? Good. You're distributing that numerator, that exponent to the numerator and the denominator. That's not a coincidence. That's what always happens. So for number 6, let's say I have x to the second over y to the fourth raised to the fourth power, let's do this third power. This is going to be x to the second raised to the third power and y to the fourth raised to the third power. What's x to the second raised to the third power? X to the 6th. What's y to the fourth raised to the third power? Y to the 12th. Okay. Let's talk about 0 exponents. Anything, or any, I should say quantity, not anything, any quantity raised to the 0 power is always what? Anybody remember? I don't know. What's your name? Philip. And what's your name? Your twin, Philip's twin. What's your name? Alex. Okay. Philip, what is it? 1. Any quantity raised to the 0 power is always 1. Where does this come from? If I have x to the 5th divided by x to the 5th, the rules of division say keep your base, subtract your exponent, right? 5 minus 5 is 0. Well, what's anything divided by itself? 1. So anything to the 0 power is always 1. Because that's essentially what it's saying. It's saying you're dividing this by itself. It's raised to the 0 power. Yes?
How come if like 0 is raised to the 0 power, it's not 1?
That's a great question because you're not allowed to divide 0 by 0. So we're saying the 0 power represents something divided by itself. But if you try to ever put 0 in the denominator of anything, it becomes undefined. You can't do that. That's why. Okay, so let's keep going. Now that we know anything to the 0 power is 1, if I have x, y, z to the 15th raised to the 0 power, since that whole quantity is to the 0 power, we're going to count it as just 1. So any quantity raised to the 0 power just becomes 1. All right, last thing is order of operations. So now what we're going to do is we're going to put the addition, the multiplication, the division, everything power to a power all together. Who remembers what's that special word for order of operations behind Charlie is? Angid? Okay. PEMDAS. Remember, we are parentheses, exponents, multiplication, division, addition, subtraction. Okay. Actually, x to the... Okay, So it looks like we have parentheses, division, multiplication, exponents. Yes. Yes. I want to work within my parentheses first. Within the parentheses, we have division, right? Is there anything I can simplify in there? Ira?
The x to the a plus 2.
Yeah. Can I cancel out the x to the raised to the a plus 3 powers because it's multiplication between them? So now we're left with x to the 2a, y to the b, times y to the 2b raised to the third power. So now I have multiplication, but I also have a power to a power. Don't I have to take care of the exponents first before multiplying? So then we're going to have y to the 2b raised to the third power is y to the 6b. So now I have x to the 2a, y to the b, times y raised to the 6b power. Nothing multiplies with x to the 2a, so I just bring it down. But y to the 1b times y to the 6b gives us y to the 7b.
When you're multiplying, I understand the rule, but why don't you have to distribute, like when you're multiplying and then with parentheses, why don't you have to?
Because there's nothing to distribute between. So normally when we distribute, let's say I have 2 times x plus 5, right? This is saying the 2 needs to go to the x, the 2 needs to go to the 5. But if I have 2 times 5x, this is just saying 2 times 5 times x. So that's why it just becomes a 10x. Does that make sense? All right, let's keep going here. So before I actually simplify anything, I want to take care of my negative exponents. I want to make sure I have all positive exponents. So my negative 15 stays on top, my 5 stays on the bottom, because I'm allowed a negative coefficient. I just don't want to deal with negative exponents. So now the x raised to the negative third power, where am I moving that to make it positive? Charlie? The denominator. So this becomes x to the third. Only the x to the third moves, nothing else, because that's the only one with the negative exponent. And the x to the second stays on the bottom. In the numerator, the y to the fourth stays on top, but the y to the negative third in the denominator, where am I going to move that to? To the numerator to make it positive. So now I'm going to have negative 15 y to the 7th over 5x to the 5th. Everyone good with what I did so far? Is there any more simplifying I can do? Yeah. Ira? Yeah, I can divide top and bottom by 5. So negative 15 divided by 5 is a negative 3. 5 divided by 5 is just 1, so I don't need to put that. So we're at negative 3y to the 7th divided by x to the 5th. All right, one more problem. I'll use x and y's. Sorry, I started with r's and s's, but I decided to use x and y's. Okay, the first thing I want to do is inside my parentheses, take care of all the negative exponents. So x to the third moves down. And do we agree y to the negative first moves up? I'm going to keep simplifying inside my parentheses. I'm not concerned with the negative 2. So inside my parentheses, we are y to the third p over x to the fifth p to the third. Are we okay so far? Everything I've done? Can I still simplify more inside those parentheses? Yeah, what can I simplify? The p's. So I'm going to have y to the third on top, x to the fifth, p to the second on the bottom. Why did that p to the second go to this bottom, Ariana? Good, because 3 is bigger than 1 and 3 was in the denominator. Okay, so here's something new. When a whole entire quantity is raised to a negative exponent, what you want to do is you want to completely switch the numerator and the denominator to make it positive. So this becomes x to the fifth, p to the second, over y to the third, now all raised to the positive second power. Am I done? No, I have to distribute in that power of 2. So this becomes x to the 10th, p to the 4th, and y to the what? 6th. And now I'm done. And we are done for the day.